So we have a triangle ABC is equilateral. So that means all the sides are congruent and the angles are also congruent. So that means that all the angles have to be 60 degrees. And so all the sides are going to be 12 since the base here, BC, is 12. We have measure angle FDC is 90, so this is a 90-degree angle. Length of FB is 3, and then the length of BC is 12. We want to find the ratio of AD to AC. Well, first note that triangle FDC is a right triangle. This is 90 degrees. This is 60 degrees. So this has to be 30 degrees because it has to add up to 180. So 90 plus 60 is 150, plus 30 is 180. And now we need to recall, if we have a 30, 60, 90 triangle, what are the lengths? Well, we call X the shortest length, and that's going to be the length that is opposite the 30-degree angle. And then the one that's 60 degrees is going to be X times root 3. And the hypotenuse is just twice the smallest side, so it's 2x. So this is what we need to use for our picture here. Now in our case, we have the hypotenuse is 15. So start with the shortest side. The shortest side is always going to be half of the hypotenuse. So half of 15 is 7.5, and that's going to go across the 30 degrees. And then for 60 degrees, you take the shortest side and then throw on a root 3. Okay, so for us, 30 degrees is over here. So we want to use shortest side times root 3, which we said was 7.5. Yeah, just 7.5, actually. The root 3 we multiply for 60, so it's actually going to be this one right here. So this whole red line is going to be 7.5 root 3. So we do know what DC is, but we want to know what AD is. So AD plus DC is going to equal AC. DC we found to be 7.5. So AC is from the equilateral triangle, that's going to be 12. Subtract both sides by 7.5. That's going to give us 4.5. Okay, so now we go back here. AD we said is 4.5. And then AC is 12. If you want, you can multiply top and bottom by 2 to get 9 over 24. And then divide it by 3 to get 3 over 8. And this is our answer.